Hello everyone. In this video we will learn the concept of integrals. What is integral of a function? See, if we have any of the function fx, if fx is a function of x and we find that d by dx of fx is represented by f dash x, then we say the integral of f dash x with respect to x is fx. It is represented as integral of f dash x dx is equal to fx. This is the reason that integral is also known as inverse of derivative. We also call it antiderivative. Also it is known as primitive. So inverse of derivative, antiderivative and primitive all are the names of the integral of a function. When we say that integral is antiderivative, so we can use this concept to find out the integral of a function, and that particular method is known as antiderivative method. Or we also call it inspection method. What we do in this method, let's learn it with some examples. Suppose we are to find out the integral of x cube by using inspection method. Then what we do? We know that x cube is the derivative of x power 4. It means we can write, we know that d by dx of x power 4 is 4x cube, but we want only x cube. So this 4 can be brought to this side. We can write here d by dx of 1 upon 4 x power 4 is equal to x cube. And hence we can say that integration of x cube with respect to x will be equal to 1 by 4 x to the power 4. One more example, suppose we want to find out the integral of e power 3x dx. This is the exponential function. So what we do, we write here again, we know that d by dx of e 3x is equal to 3 into e to the power 3x. 3 is a constant, so this can be transposed to this side. So we can write d by dx of 1 upon 3 e power 3x is e to the power 3x. It means we can say that integration of e to the power 3x with respect to x will be 1 upon 3 e to the power 3x. One more example, suppose we want to find out the integral of cos of 2x dx. We should know what is the function whose derivative is cos 2x, and that we can find from sin 2x. So we can write, we know that d by dx of sin 2x is equal to 2 cos of 2x. This 2 again we can transform this side. We can write d by dx of 1 upon 2 sin 2x is equal to cos 2x. It means the integration of cos 2x with respect to x is equal to 1 upon 2 sine of 2x. This is the way we can use inspection method or antiderivative method to find the integral of a function. But let's see one more example. Suppose you have been given a function fx and that is x square plus 2. If we find the derivative of fx, that is f dash x, will that be 2x plus 0 or we say 2x? But when we find the integral of 2x with respect to x, that is only x square. So where this 2 has gone? Because the derivative of a constant is 0, that is why that particular part will not come in this. And this is the only reason that we write integration of 2x dx is x square plus c. So we take a constant c, which is known as constant of integration. This is known as constant of integration. So when we find the integral of any of the function, then we use c, a constant, thinking that a constant is a part of that particular function. Some of the standard formulae of integration can be found out by using inspection method only. Like we know that d by dx of x power n is equal to n into x to the power n minus 1. Power is reduced by 1. It means if we write d by dx of x power n plus 1, that will be n plus 1 into x to the power n. That gives you d by dx of x power n plus 1 upon n plus 1 is equal to x to the power n. It means we can make a formula that integration of x power n dx, that is x power n with respect to x, is equal to x power n plus 1 upon n plus 1 plus c. Here we can see the power of x has been increased by 1, and that power whatever is coming here, that is only coming in the denominator of that function. One more formula we can take here. We know that d by dx of log x with base e is equal to 1 upon x. It means integration of 1 upon x with respect to x can be taken as log of x plus c. We use here modulus because we know the domain of log x is the set of positive real numbers. After learning the concept of integral as antiderivative, we can make a list of the formulae that are known as standard formulae of integrals here. But in that, what I am going to use, I will be making this particular list in two parts. One part I will write the derivatives and another I will write the integrals of the function, so that we can make out the difference between the two. So we are taking here derivative, and on this side we are taking integral. The first formula for derivative, we have d by dx x power n is equal to n into x power n minus 1. In integration, we have integration of x power n dx, that is equal to x power n plus 1 upon n plus 1 plus c. Here the power is reduced, here the power of x is increased by 1. Second formula, we have d by dx of e power x is equal to ex only, and hence we can have integration of ex with respect to x is e power x plus c. Third formula, we have d by dx of log x with base e is equal to 1 upon x. So integration of 1 upon x is taken as log of x plus c. Fourth formula, we have d by dx of ax is equal to ax into log of a with base e. So the integral of ax will be ax upon log of a plus c. Fifth formula, we have d by dx of x is 1, and hence we can write integration of 1 dx is x plus c. Sixth formula, in derivative we have d by dx of sin x is equal to cos x. So integration of cos x will be sin x plus c. Seventh formula, we have d by dx of cos x is minus sin x. It means the integration of sin x here will be minus cos x plus c. So we have to see the difference, that d by dx of sin x is plus cos x, whereas integration of sin x is minus cos x. Next formula we have d by dx of tan x is sec square x. So the integration of sec square x will be tan x plus c. Ninth formula is d by dx of cot x is minus cos x square x. So integration of cos x square x will be minus cot x. 10th formula is d by dx of sec x, that is equal to sec x into tan x. So integration of sec x into tan x will be sec x plus c. Next formula is d by dx of cosec x is minus cosec x into cot x. So integration of cosec x into cot x is minus cosec x plus c. 12th formula is d by dx of sin inverse x is equal to 1 upon root of 1 minus x square. It means integration of 1 upon root of 1 minus x square will be sin inverse x plus c. But the next formula here we have d by dx of cos inverse x is minus 1 upon root of 1 minus x square. It means what we can write, integration of this can also be written as minus cos inverse x plus c. The next two formulae we have, 14th is d by dx of tan inverse x is 1 upon 1 plus x square and d by dx of cot inverse x is minus 1 upon 1 plus x square. So can we say here that integration of 1 upon 1 plus x square is tan inverse x plus c, and also it is minus cot inverse x plus c. Next two formulae we have d by dx of sec inverse x is equal to 1 upon x into root of x square minus 1 and d by dx of cosec inverse x is 1 upon x into root of x square minus 1 but with a negative sign. So here integration of 1 upon x root of x square minus 1 will be sec inverse x plus c, or we can write minus cosec inverse x plus c. These are standard formulae of integrals, and in the next video we will learn how to apply these formulae to find out the indefinite integral of functions, what are the rules and what are the methods of integration.